How are you?
Good. Good to hear from you again.
All right. It's 12:32. I want to be respectful of everybody's time, so I think we're going to go ahead and get today's program started. For those of you who don't know me, my name is Kevin Day. I'm co-chair of the Baltimore chapter of the Building Enclosure Council. Today's presentation I'm really excited about. As you all know, it's about hybrid panelization. And today we're going to be hearing from Corey Robbins, who heads up business development for EDA Contractors. He's also the president of CSI Philly. Now, for those of you who don't know EDA Contractors, they specialize in exterior envelopes of commercial, institutional, and industrial buildings located just outside of Philly. And what I really find intriguing and appreciate about EDA, and you see this on their website, is they have this motto of successful together, where they really have this attitude of working in conjunction with architects and designers to really strive towards really well-crafted solutions and really serving their customers. And I think for those of you who know Corey, he is very passionate about sharing knowledge and working together. We'll talk a little bit more about how that plays itself out in the case study that we'll hear about here today. So for over a decade, Corey, he's been an established presenter with EDA Contractors, talking in the realm of building envelopes. And he's really a forward-thinking guy. Aside from the hybrid panelization, he's got some other, I would say, somewhat controversial topics about exterior building envelope warranties. Maybe that will be something we'll discuss in the future. Maybe not, we'll see. His aim is really to really look for positive change in the construction industry, really looking to align installers and architects towards that common goal, being collaborative and providing the best quality product for the owner of the building. So with that, I'm going to turn it over to you, Corey, and please walk us through this innovative hybrid panelization. Absolutely.
Thank you. I'm blushing. As you can tell, I wanted to turn my video off because I'm just blushing so much. Thank you, Kevin. No, I'm thrilled to be here. Really excited to talk with people who, I've presented this in different situations before where it goes way over people's heads. And it's great to present to Building Enclosure Council. This is right up your alley. So I'm hoping this is going to be helpful and you learn something. Again, my name's Corey Robbins. I work for EDA Contractors. You can see also, well, in one of the many faces here, Jeff Dorneman is also here. He is the estimator and project manager of the project or the case study we're about to talk about. So this is his baby in a sense that we were very close to losing the project. He came up with a very interesting scenario of a way to panelize in a different way. And Gilbane loved it. So did BLT Architects. And yes, that is their name, Bacon, Lettuce, and Tomato. And yeah, they loved it. And we went right with it. And man, it came, we knew it was going to be a good play. And we didn't realize all the pros that were going to happen from it. And after he kept going through it, we decided, man, we have to make this a case study. We have to explain to people so that they're aware of how this thing goes. And I'm yammering, so I will stop. So I want to do now basically just show you my screen. So give me 1 second. Okay, 1 second. Okay. So first off, Kevin or Jeff or anybody, can someone clue me in? You can see this, right? Okay, good. Just want to make sure. I don't want to be just talking to myself like a crazy person. All right, cool. Okay, so you can see here, we basically got to the Philadelphia Live Casino. That's where this case study takes place. It's right near the stadiums in Philadelphia, Eagles, Phillies, blah, 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 blah. And they decided to put a casino, hotel, and a garage. It was all on one site. The GC in question was, learning objectives. I probably should have mentioned that first. This is obviously AIA as well as HSW accredited. So you should get your credits for this. Kevin's taking care of that again. Thank you, Kevin, for saving our tail there. But the project overview. Okay, so there was the GC in question was Gilbane, Philadelphia. The architect in question was BLT Architects. They're a big architect firm in Philadelphia. They have a lot of heavy hitting projects. We submitted a bid, as you can see here, was a million square feet, is around 9 acres. It was absolutely massive. And this thing was, they were really flirting toward this project for a little under a decade. And then all of a sudden, as all projects are, it was fast tracked. Go as fast as you can. You know what I mean? So they were really worried about their gaming license being, revoked if they didn't get it opened in time. And so that's why they started leaning toward panelization. We do not do panelization. We at EDA are, this is not a commercial for EDA, but obviously you need to know who we are. And we're an installer. We are a subcontractor in Philadelphia, union-based, carpentry, roofing, and we do exterior envelopes. We try to take on as much as the scope as the GC is willing to. Oh, someone's, I don't know, can I mute them? Hey, I can mute anybody. Great. I just have full rights to mute people. That's great. All right. So like we really wanted to attack this one and absorb as much of the envelope as we can in the enclosure. The more we have the ability to control, it's just the better it's going to come out. But they were going toward panelization, and we, our biggest motto, as he said, was successful together. And our second big motto of being in the enclosure is watertight. One company, watertight. Okay. And we know that with panelization, if there's someone here who is a prefabricator, I apologize in advance. But when it comes to prefabricating and panelizing the wall, we believe that it is doomed to leak. And what I mean by that is that you have these giant panels that come in from the studs all the way out to the cladding, right? So it's studs, sheathing, air vapor barrier, subframing, insulation, cladding, right? So it's a lot of layers to it. They come out in these huge panels. You caulk the seams, and then that's it, And for us, caulking the seams is simply not enough. Caulk only lasts so long, and if there is a leak, getting back to that caulk is nearly impossible. You have to pull off these giant panels, and we were really worried about that. We know we can't obviously compete, and we think it's a recipe for a leak. So we decided to, I say we, Jeff Dorneman decided to pitch an idea, like legitimately on a napkin, to Gilbane and explain his idea. And that's what we're getting into now. So as I said, typical panelization, the pros are, accelerated schedule. They believe the delivery method and the price is very fast. You get to use Revit models a lot more, which is obviously terrific for architects, is you get to have your hands in the cookie jar much later in the process, which we love. It's a good thing to have the architect's brain in the mix throughout. The cons, as we said, are the weather tightness. That's our biggest con. We believe that caulk, no caulk lasts forever. And when you look at the joints of these panels, great, it's going to be a half inch the whole way down. But as you know, buildings breathe, no matter what you do, field measurement, it comes out. We've seen panels between a 10-foot, it can go from a half inch to 1.5 inches. And then you're going to hold a caulk joint 1.5 inches. It's not going to hold, and that's what we were really worried about. So we're trying to get away from that. And as you see, the last con, tolerances, Jeff will be able to talk to that a little bit more than me. When it comes to constructability and adaptability, your ability to change, as in the architect and the owner, your ability to change the aesthetics of the material or where you want, a TV to be or whatever, you have to make those decisions light years early, very, very early in the process. And once it starts going and the prefabrication begins, it's very difficult to change those things because you got to go through multiple materials. And so, the architect's ability to change aesthetics as it goes and to be agile is almost impossible. So that's what another big con was. So our idea, we call it the hybrid approach. You could call it quasi-panelization. You can call it whatever you want. You can call it Susan if you like. But what we do is basically say, so we think that we can get the building watertight faster. Now, we're not going to have the cladding on before. What we're going to do is have the prefabrication specialist build their panels the way they were, from the studs all the way out to the, the sheathing, the air vapor barrier, and then stop. So they bring these massive panels out. We still caulk the seams, but then we put on air vapor barrier tape, whether it be Henry or 3M or whatever, to give it a monolithic air barrier or a monolithic vapor barrier, right? And so we thought that that's the best way to do it, so that if there is going to be a leak, it's not going to happen in those caulks. It might happen in penetrations, but the chances are very, very low. And it gets the exterior enclosure off the critical path, meaning that once those are up and those seams are taped, the interior can start. And the casino loved that because they were very worried about their gaming license. They wanted to start the interior early. We gave them, I think it was Jeff, you can probably jump in here. We gave them a 10-week head start in comparison to what the panelizers or the prefabricators promised. And in the end, I think it was $1 million more cost effective. Is that, I mean, maybe not on the dot, but is that fair, Jeff?
That's fair.
Okay. Yeah. Would you like to finish this? I mean, I've been talking. This is your baby. Do you want to go?
Yeah, I can go wherever.
All right, go for it, Jeff.
Pretty much everything he said is absolutely correct. What we found that made this such an effective approach is, number one, the people that did our backup panels did everything from estimate forward in Revit. So we had a BIM model up and running day one. That was a living, breathing thing that was dropped into the main model for the building itself. There was a lot of pre-release steel and steel that was already up. And so we were able to find a lot of building clashes with the steel and the panels and make adjustments to the panels, obviously, before they were built or shipped. The other thing it did, it made it very easy for the architect to prioritize submittals. There's about 1,100 lights that go around, and string lights that go all the way around this thing that would have all been pre-installed with the panels before they ever came to the job. Well, they didn't know what light fixture they wanted to use. They didn't know what color it had to be, the projection. They wanted to see it on a mock-up. Well, that would have all stopped any of the panels from even starting to be made. Secondly, they added a TV screen to this thing that's about, I don't know, 30, 40 feet along a curve that needed power. It needed anchorage back that didn't even have steel for it. All those penetrations had to be coordinated back to structure. It gave us time to figure these things out while not compromising the schedule of the inside of the building. Because the penetrations alone are enormous between all the signage. They changed. FanDuel got involved, so the lettering of a signage had to change. The whole package had to change for the sign. There were all these things. The other thing that we brought into this, because there are limitations to any kind of panelization. Horizontal surfaces such as soffits, ceilings, that kind of stuff doesn't really lend itself. So due to the magnitude of this job, I also partnered with a local carpentry firm, Component Assemblies, and they already had all the framing for all the soffits. As we started building the enclosure, the general contractor came to us because the central utility plant of this casino is on the second floor, and they had no idea how they were getting their switch gear and all the electrical components and HVAC stuff in the building. So they said, well, can we do something different here? So I said, we'll stick frame this. We won't panelize it. We left leave outs in the building in locations because we were already going to have the carpenters there that we would leave open. They would take care of the temporary protection. And when they were ready to close them in, we could either put the panels up or we could do it stick frame, which is what we ended up doing. So it gave some flexibility to the general contractor on how they needed to mobilize and sequence the job from a logistical standpoint as well. You can go ahead, Corey.
No, thank you again, Jeff. I appreciate your time. Again, he's the estimator as well as the project manager of this project. So this was his baby. And I know whenever he drives by it, he calls me and says, can you believe we did this? Like it was a big one. It's a big, if you haven't been down.
2+ years of my life, I'll never get back.
If you haven't been to Philadelphia, down in that area, you see it's a shocking sight. It's huge. So you can see right here, it says stick built, when needed. I didn't really finish my explanation. You go all the way up to the AVB, you tape those seams, and then we will build stick out from there. But again, it gives that ability for the interior to begin. And you also have the ability to be agile as well. This was part of the architect just kind of showing their the different clashes and things of that nature that came into play when they're working the BIM model in Revit. Jeff, do you want to speak to this? I mean, we can go past it, but I don't want to
That's-
stay on it too
that's-
long.
That's what it did. Yeah, and it's, when we look at some of the pictures that on the bottom thing, that the whole front, the geometry of the whole front portico area, it's in several geometries. It goes up and slopes and comes down. There's a funnel, but that's all held up by like a almost 4-foot tall bridge girder truss. That all had to be coordinated because the ceilings on the underside of this thing are in 4 different levels. It's just insane. There was something on the previous slide I was going to say, but go ahead, Corey. I'll come. I can't remember what it was.
Well, and also just remember, like, as we're going through this, there's going to be a very simple over and over phrase that we're saying which is, a lot of these decisions that happen late in the game, because that's the way construction is. Nothing ever goes exactly according to plan. Things change, aesthetics change, fan duels involved. There's a new TV. All these decisions would have been moot, right? Because, like, if you have to change this TV screen and the prefab has already done that spot, and they don't have the penetrations, it's going to be like, you can't have that TV screen because we don't have the ability to put it up. So
not without damaging the panels and undoing what you've already done. I mean, anything can be done, but
well, just dollars. The owner is going to bleed money, right? So this concept is, if it's anything, it's very agile. You know what I mean? The one thing that my favorite part of it, here, I want to bring up one thing really quickly.
I'm going to cut you off real quick, Corey.
Oh, okay.
The other thing that was a byproduct of this is obviously nobody expected COVID to hit in the middle of a construction project that was on such a tight timeline. We actually were shut down for about 4 to 6 weeks. But before that shutdown, we had gotten the casino 100% watertight, which allowed, you were allowed to have emergency service people here to monitor roof conditions and stuff like that, but you couldn't do any actual construction. But the days things started back up, it wasn't like we had to reinvent the wheel. They already had enclosed areas to work. It was winter still up here. And it was really, in my opinion, was probably the saving grace of what got them through to be able to finish this thing on time, plus a lot of overtime at the end of the job.
Well, the only thing I really wanted to show was just, again, the ability to be very agile. So here's a really interesting, give me 1 second, we just drag it over. Or not. Okay, here we go. So you can see right here, this is kind of where I guess that's not really that great of a picture. 1 second, I apologize.
That's the leave out.
This is the leave out right here.
What you just clicked, yeah.
So you can see right there. It's a little
left. On the left,
you can see right here what happened. Again, this is what I mean by the agility of this concept versus panelization, right? So they were having trouble. Man, how are we going to get this HVAC in? Oh my gosh, we already closed up the building. Where are we going to bring it? We had the ability to just leave out a giant area on the exterior. They brought the HVAC in this way, and then we stick built the rest of it. If you're working with a normal panelization project, this would be not impossible, but as Jeff said, very expensive. You know what I mean?
And we built the parapet condition ahead of time and just hadn't been done when this picture was taken so that they could temp in the roof as well. So the roof was dry. This thing was 100% dried in, and they were working round the clock on the inside of the building.
Yeah. So it's more, again, I'm not trying to bring a bunch of random pictures. So you're like, what are we looking at? It's just more, this concept is very agile. So whenever you hear about panelization and them being very fast, they are fast. But they don't dry in as fast as this concept does. And it gives the interior the ability to kind of start moving very early, gets the watertight off the critical path, which is huge. So now we're going to start going into the different parts of the project. And we only have Jeff for a limited amount of time. So I wanted to get some words out of him before he skedaddles and goes to whatever it is he's doing right now. So this is one of the parts. It's called the eyebrow. And Jeff, please just go for it.
Well, the main dry line of the building is actually back behind. You can see the panels went behind this. This was a freestanding structure, but it also had a panelized wall system that formed the exterior of it. So there wasn't, panelization is usually typically built around a balloon framing principle. This was, while balloon framed, we were right against the steel and there, because of clashes in how their steel was, we really didn't have a lot of room to move out. So we had to almost go tight to the steel. So we still built, to his point of kind of being flexible, we built the panel modules as they were shown, but we left off the sheathing and the air barrier. And so we could get directly to the connections of the frame back to the steel. And then we field applied the sheathing and the air barrier. Again, was something that had to be modified on the fly. And we were able to make a very quick decision to go this route. There's the backup panels actually just without the sheathing and the air barrier. It wasn't as critical. I mean, the air barrier could be field installed because, again, the dry line was back behind this whole structure. It was freestanding outboard. It had 2 connections with expansion joints. But the rest of that, nothing penetrated the building itself. You go ahead, Corey.
No, it's as he said, you know, this is just another example of how this concept, you know, just went off without a hitch. And the more and more we went through it, Jeff realized, oh my gosh, this is another pro. Oh my gosh, thank God we did it this way. Oh, thank gosh we did it this way. You know what I mean? Sorry, go ahead, Jeff.
Well, and to that picture there on the left, you can see obviously all the horizontal lines are the subframing girts that were put on afterwards, but the white vertical lines are the detailing tape. So after those joints from the panels were caulked, we then put an air barrier transition membrane over that from panel to panel with the proper manufacturer's lap to allow this to be considered a continuous air barrier, which was honestly obviously there's some timing and dry-in conditions that they liked the idea of the schedule. But what really sold the architect and the owner was that they had a continuous air barrier, which you can say a caulk joint is a continuous air barrier, that's fine. But in my opinion, if the caulk joint isn't consistent and being held consistent, because as you said, we've had jobs where we've gone and looked at panel joints that go from 1/2 to 2 inches.
Right.
As the metal or whatever they're attached to expands and contracts, it's going to pull on that joint. It's going to fail.
Right.
And over time, it's going to fail regardless, unless you're using some kind of non-curing butyl, which isn't what it is typically used.
Right.
So this was our solution, and knock on wood, building's still open and they're still making a lot of money.
Yeah, and the bad part as well about those caulk joints failing is that getting back to them to recaulk it is extremely difficult. You know, it's way deep in that crevice and it's very difficult to get back there. And again, it's not impossible, but it's very expensive. You know what I mean? So here's kind of the complete version of the eyebrow in the end, so you can kind of see how it comes out.
This is where I want to go back one. This is what I want to make sure, and it doesn't just apply to here because this is really a non-conditioned space, but we have the same kind of signage on the other side of the building. Look at the level of penetrations that had to go through this wall. That all would have had to be, at least the penetration or sleeve would have had to been in before any of this stuff started to be erected. And because we have a backup panel which has the sheathing and the air barrier on it, then the ACM panel. Outboard of that, there's the whole string of ribbon lights that you see at the bottom right before the soffit panels.
Right here.
In addition to that, you then had standoffs that had all these vertical fins, which were a system from, I can't remember the name of the company. Then on top of that, there was signage. All these different levels and spaces between how far each one of these standoffs, because this thing curves out. Each standoff was different. This is where the BIM and having the modeling and really be able to go in and see where do the letters need to be off the face of the panel, where do the lights need to be, and really do it in 3D and really understand the spacing and how all this was going to work and have it in 3D to explain to everybody. So everybody was on the same page. The sequence was very easy to understand of who had to go when and where. And it made for a much cleaner job because I'm not usually a big fan of signage guys and people that penetrate my work. This was the cleanest job I've ever done in 30 years.
Yeah, and they got to make those decisions. I say they, architect and the owner, got to make the decisions of all this stuff just not really late, but a little bit later. You know, they had a little bit more time because they knew that these weren't, you know, they weren't in the queue to be fabricated 6 months ago. You know what I mean? You can kind of move as you go and be agile. So now there's a portico cloud scan. This is more just, use the cloud scan, but Jeff can go a lot more into this one. It is fascinating. This was definitely the crown jewel of the entire, I guess, hotel, garage.
This is the main drop-off portico. It's about 20,000 gross square feet undercover. It has an ACM soffit, the farthest thing out to the bottom of the screen. That's not flat. It's on a slope. Then it has a return panel that comes up the backside and forms a border, because there's a linear wood ceiling that looks like a mogul ski slope. If you're a big fan of the Olympics, that's the kind of the geometry. It was
You
about
just show them what that looks like as you're talking.
250 faceted ceilings that were put together to make this.
Yeah, you can kind of see right here. Sorry to cut you off. You can see right here the wood paneling and the ACM. Just so you have a visual. Sorry, continue, Jeff.
Then in the middle, the highest point is just a ginormous digital art screen that actually plays videos and pictures as they move across the screen, whether it's cards being flipped out like they're playing blackjack, or that one's a floral pattern that moves and is continually ongoing. It's massive. It was a job unto itself.
Yep.
Outboard of the building, but it really is. That's the first thing that catches your eye when you pull up to the valet drop off.
Absolutely. Do you want to add anything to this? You want to go to the next part? I mean, now I kind of skipped to jump a bunch of stuff, but is there anything?
You can go.
Keep going. Okay. Yeah. This is, as I said, the crown jewel. There's a lot of things that go into this, as you said, it's a job to itself, but we don't want to hold everybody. We want to have as many questions as we can in the end. So area G is the design model coordinator. You can see right here all the different stuff that went in. You know what, Jeff, please, you're here.
Well, there were a bunch of clashes. This is one of whether some of the early steel was when you come around the chiller, it actually curls up onto the roof of the building. Plus it goes down the main street in front of it. And there's an intersection that had to be watertight because of the coping condition that kind of just came out of nowhere. I mean, it was always there, but it had to feather from not having a coping or a wall to being one. And this really helped understand that some of the steel wasn't there that needed to support the panels, and that we had some clashes on how the panels were going to fit. Because at the end of the day, this is a segmented wall. They weren't curved panels, but we did at the end of each panel, I put a triangular plate kerf block at the edge of them so that they kind of fit together, and it took the geometry and it made it a little smoother than just butting two squares with a huge gap at the end of each panel. That's the curvature below what you just saw. There's two more levels of panels that eventually went on top of that. But that's the base layer that forms the soffit around the perimeter.
Yeah, and this is a really good representation of the monolithic air barrier. You can see the tape that was used over the caulk joint, so we're not ditching the caulk joint. It's still being included, but you tape on top of it for that extra, save of monolithic air barrier. You can also see all these extrusions, which you will see will turn into, I think that's where the TV was, right? Yeah.
Up top, yeah.
Yep. So you can see as you go through.
That's the cold form framing of the soffit below. We had to stick build, so all the soffits were stick built all the way around the job.
Right.
That's your TV screen.
Yeah, so you can see the giant video screen, and this was changed not last second, but near the finish line. So for all of these extrusions that went through, as you can see, all of these ACM panels, this would have been dang near impossible. You know what I mean? They would have had to stuck with whatever TV they did, a screen that they thought of in the very beginning, and versus changing it, they wouldn't have had the chance to do so unless incurring massive costs. So
back to the original thing about the shop drawings and whatnot. There were 6 different colors of ACM on this job, and there were 12 different modules of how those 6 colors went together. The set of shop drawings for this job is about 200 pages long, because we basically did each module individually coordinated back to the backup panel that it was fastened to. So it was very easy to check the color sequence, how things went for the architect to check it. And it was easy for the guys to come out to the job, because that's how we built them in the shop. When we built these panels, they were built in the order we were building the job, in the color sequence, and everybody in the shop was on the same page as the guys in the field.
Yeah, I mean, this is it. This is a great representation of, the ability to make agile decisions late in the game.
I will say it's not the best color selection in my opinion, but I'm not.
Subjective, Jeff. It's subjective. This is the casino corner. This is the final, if you will, from the side. Like I said, it's a really impressive building. This is the last part. If you guys, anybody who's falling asleep over there, hang in there. This is the last part we're going to talk about. Again, I can speak to it, but Jeff, this is your baby. I'd much prefer you speak to it.
There was some flexibility to this, because not all the times are you working off of just a steel structure. this location on the hotel, we had one area, which is a concrete shear wall for the whole hotel. So same thing, we panelized it, but we coordinated with the concrete subcontractor ahead of time to provide him the embeds that these panels were attached to. We left strips of the sheathing off so we could get back to the connection, then field installed a small amount of sheathing at each level, about 16 inches, and went straight up the wall. Now, luckily for us, or unluckily as the case may be, this project is directly in the landing path of the Philadelphia International Airport. So the tower crane barely had enough room. The last panel actually had to be kind of tilted as it got up because it wouldn't fit over the structure because the height of the tower crane could not be lifted anymore, to add one more insult to injury. So
Yeah. Yeah, I mean, and you can see right here all the subframing going up, using the use of the swing to kind of aid with the tower crane, which is obviously, critical to the success of this part. Oh, we do have one more. I apologize. This is the bride's veil. I forgot about the veil.
This gets a little bit off the panelization topic, but this is just something that we can do. There was a perforated screen wall all the way around the parking garage. Originally, as designed, the level, it was 9-story parking garage. They made a deal with the Phillies because the Phillies couldn't see out of center field to see downtown Philadelphia. And all of a sudden, the parking garage became 5 stories with no design. So we kind of had to do it on the fly. The geometry, as you can see, comes off the edge of the building about 6 to 8 feet at the corners. So there's a lot of, multi-level trusses and framing that had to go in to make all this work. We coordinated all the embeds that we had to supply to the concrete, the precaster, all the subframing, and then ultimately all the panels to make sure that it fit the way they wanted to do. Next picture is probably better. That actually shows the panels.
Yeah, I was about to say, this is where the money shot.
It's lit up like a Christmas tree. And this one is another one. They didn't use all 6 colors on this one. They used 4 of the colors, 3 for panels and 1 for the subframing. So I went to a person that could fabricate this and do all the painting in-house so we can keep everything consistent.
Yeah, and just like Kevin said in the very beginning, we're all about, thank you again for saying our motto of successful together, but this is a great example of us working with the architect. Sometimes that doesn't happen between subcontractors and architect. We're a big believer that it basically is essential, and throughout the entirety of this, the shop drawing phase, the installation phase, the architect was knee deep with Jeff going through all of this. And that's why it became, such a great case study. A lot of times they're at war, if you will, but with this one, everyone was working together to beat that schedule to make sure they didn't lose their gaming license. And I think you made it by like a day or two. How close was it?
It was a week.
It was a week.
Wasn't that close. This one, to his point, that we worked with the architect with perforated panels, based on the engineering and design, and there was a wind study on this building. They kept wanting more and more open air because obviously the parking garage, you got to maintain a certain open air, free air requirement, or you got to ventilate it. We got close, but the pattern they wanted was failing all the calcs for the wind study and would be astronomical to increase the size of the aluminum panels. So what we ended up doing with a collaborated effort with him is we opened up the space on the panels by about a half of an inch or an inch on each side and made the panels a little bit smaller that you'd never know if you weren't involved with 3 months of wind study design and perforation design, but it looks the same as it does aesthetically. But the architect had to come up with a solution of how he could open the panels in the areas between the panels to help increase the free air to still meet the ventilation requirements. And he did. And so that was a tremendous help that we actually finalized while I was in Canada with my daughter on a skating competition in a hotel room. But, we got it done. So that's.
Tell us how you really feel, Jeff. Nah, shit. All right. So, but that's really it. We could go way deep, way deeper into this thing. We could talk a lot more about it, but we'd much rather have, again, because this is the BEC, this is not just some, random office. This is, we are actually excited to hear the questions you guys have to bring to the table. So,
and I will say one last thing before that. There were 2 separate envelope consultants on this job, each inspecting. One for the owner, one for the architect and general contractor. So it wasn't like this thing we just flew by night and just didn't have any supervision over what we were doing and making sure it wasn't passing tests.
Right.
It was very highly scrutinized, and there were some details we had to work out for transitions to roofs, for copings, and just bad details that eventually showed their ugly head as all this geometry that's not flat came together. But it was a collaborative effort, and it did have an envelope consultant blessed. So blessing it at the end.
Yeah, they audit the work. They're very important. So questions, please. I saw Kevin showed his face, so thank you. I don't know if you're going to moderate the questions. I appreciate it. But yeah.
Sure. Thank you both for walking that us through the approach and the different projects here. I do want to open it up. I think people may be able to unmute themselves. Feel free to ask questions, or you can type it into the chat, and I will convey those questions. So while we're waiting for people to think of their questions, maybe I'll start off. You talked a lot about the detriments of a traditional panelized system that is basically stitched together by a sealant joint. And your approach was that using the tape was a much more robust approach. Can you talk about why you decided to go with both the sealant joint and the tape?
Well, part of the sealant joint is just, number one, you need a dry line, but number two, you do have differential movement because you're putting two pieces of aluminum and attaching it to a steel structure. There is going to be movement. And the ACM panels themselves, outboard, was a totally wet sealed caulk system as well. I didn't want to throw the architect too much for a loop because it was part of his design and how he wanted it in there. So he had the caulk joint there. So I left it in case that was ever going to be something where you say, well, you don't have a caulk joint. We always have a caulk joint. So I said, okay, we're not going to eliminate what you've already designed. We're just going to improve on what you've designed.
Mm-hmm. Belt and suspenders, right? Belt and suspenders.
That's basically what it is.
So a follow-up to that is, were there any issues, or what considerations were put in place to make sure that first sealant joint was able to properly cure before the tape went on after it?
First, there's two. I put two sealant joints. There's one deeper and there's one near the outer face.
Mm-hmm.
The panels went up, and it was probably a good month after we put the detail tape up, because we wanted to get the panels went up fairly quickly, and we wanted to get far enough ahead. As far as, we have a QC program with our roofing that we do all the air barrier. He inspected the joints when they were sprayed off that they were good. We went through and went all the way through at one time and did the tape and the subframing. The insulation came on a little bit later than that. So I would say mostly from our QC program and then being inspected was when we released to go ahead and tape over.
Okay. We have a few questions starting to roll in here. One about, were there any unexpected problem with air tightness testing?
We did have a couple, yes. Some of that was because of penetrations. We had some over on the front of the portico. They changed the drum drip and how they needed to get to the dry system for the sprinklers out there a couple times. And every time they did that, they opened up the wall. And did they go back and close it up correctly? There were a couple of times they came in and did it themselves, and we weren't involved. And all of a sudden they said they took care of it. And there was an air leak and a draft on the inside of the building. The beauty of this system is it is open on the back. The interior carpentry trade or sheetrock subcontractor closes off and insulates the inside of the building. We inspected it from the inside and the outside. Obviously, if we could see daylight, obviously we know we have a problem. Where that bridge girder truss came out away from the portico was a huge gap that we had to spray foam and do some other things to make sure it was tight before the blue skin went on. And on the other side at the main 10th Street entry, same thing. It was because that other eyebrow structure was freestanding and only tied in really two spots. Those were the last things that were closed up. And there was a draft at that location as well that we had to go back and address before we closed the building in. And you could kind of see some of these coming with the geometry of the building and how things were pulling away and just the shape of it. And so those were more tightly tested. In a couple areas, we actually hose streamed them to see if there was any water coming through more than I was worried about air. Because worst comes to worst, the back side of the building was open. We could have sealed something from the inside if we had to. So it was more the exterior of the water I was worried about at the time.
Thank you. Next question. So we all know that the field of a an air barrier, right, is the easiest thing. And it's always the penetrations and the sealants that tend to fail.
Yep.
Let's talk about those penetrations, and maybe we think about the TV screen where there were all of those penetrations there. Walk us through the sequence. Were those areas all stick built, or how did you get those structural connections back through the panelized backup wall?
In most cases, if they weren't previously planned, where we set the panel around them and cut a hole for them, and kind of like these were all standoffs for the main sign on the top of the hotel. We knew what they were going to do. They went through and attached their system, and then we sealed back to them after they were in. Every penetration, which I can't tell you how many times I said in meetings, had to be hard conduit. It couldn't be flex coming through the wall. And that was very well coordinated. Most of the penetrations that were not part of the original design were field done like that.
Right, I just wanted to show it. Sorry, Jack, continue.
No, and so we had to have, and that's where the envelope consultant came in on many occasions and checked all these penetrations, because that one sign where FanDuel is had 120 just in that one location. So trying to get an ACM panel around it, plus get all the other stuff around it, it was a monumental task for those. But a lot of them were coordinated ahead of time. The signage was pretty much, except for the ones that got changed. Where we could leave things out and not field drill it in the field, we did. If we had to, then that's exactly what it is. An area was cut out, it was repaired, and then it was detailed all the way around it and sealed like a penetration where you put like a hose or electrical conduit coming through the wall.
All right. And so, Corey, maybe if you could bring that back up. So the other kind of penetrations are smaller, specifically how the furring is attached. You've got your panelized backup, but then you stick built everything outboard of that, correct?
Outboard of what?
Of the air barrier.
Yes, everything was stick built outboard of the air barrier. That is correct.
And so for the furring, and I thought I saw a picture of the detail or not, but walk us through there. What was the approach for all those fasteners that for the furring strips? Was
every fastener, we actually got Henry involved. There's a large, I won't say disagreement, but there's differing opinions of whether you put silicone, you put urethane or some kind of caulk on the back of a Z-girt, or do you dip your screws? Do you put them on the heads? At the end of the day, the product is sold and manufactured to be a self-sealing membrane. You can't back a screw out. That's correct. If you miss, you leave it in. And you should, if you miss, you should seal that one with detail tape. Every fastener on this job was a gasketed fastener. So with the compression, when we had areas that I was concerned about, yes, there was additional sealant put on the back of the Z-girt. But as a standard course of practice, which we had signed off on by Henry and the air barrier consultant or exterior envelope consultant, the gasketed screws and the self-sealing or self-healing membrane was how it was treated for the penetrations from fasteners.
So what you brought to the table, if I understand it correctly, was the manufacturer was saying that it is self-sealing, but you guys
it's a self-healing membrane. So, but we've made it, you need the compression of the system going against it to make it work. So that's why we use the gasketed fastener. So we could then make the tension of the fastener against that Z-girt tight to the substrate.
And you mentioned that there are some areas that you were concerned about where you additionally,
yeah,
I think you said silicone sealing. Can you maybe walk us through, what were those conditions? What led you to?
It was where those big girder trusses came through the building, and there were bigger gaps in the building. And I didn't want one other thing. I would take it to the approach of, as Corey said earlier, belts and suspenders. Did I need to do it? No. But it was such a big hole when it originally started, and there were such big thing. The girder truss in the front of the building is supporting that whole portico share. There's 2 beams. That's it. And it comes to one single post. So it's massive, the hole and it's hard to get the geometry of an I-beam to get that sealed 100% tight. And then you're going to run Z-girts to it and framing to it. So those were stripped in a little bit more diligently, I'll say, and there was actually some spray foam on the inside of that one, because I was concerned about it, not because the envelope consultant or Henry said I had to. We got the blessing of the self-heal. The membrane itself, as manufactured, is a self-healing membrane. As long as you don't pull back out from it and open the hole, you don't have to seal it. Now, if it's in the specifications that we would have had to have done that, there are many jobs that are that you either have to put it on the back of the Z or you have to dip the screws. We obviously do that. This was not a job that called for that to be done, but I wanted to cover my own, you know what, so I had to Henry come say that that was acceptable and would be sufficient for the design, and it was in compliance with the original design from the architect.
Got it. Got it. Well, I'm going to encourage people to keep typing questions into the chat. I certainly have a few more. Let's get back into the initial decision to kind of pivot from fully panelized to a hybrid system. Corey, can you refresh my memory at what point in time during design and construction that occurred? Where was that in the duration of the project?
I believe it was during the bid. It was during the bid process. And Jeff, unmute yourself again. I just muted you because you're on the phone. So, but it was during the bid process where we were kind of going back and forth, and we feel like we were getting closer and closer to not getting awarded the job. And we just
almost not being able to bid on the job at all.
Exactly. And we were trying to kind of explain that, those caulk joints were bound to fail, and they were, well, the money works. And Jeff was like, well, wait a minute, we can do it faster if we do it this way. And that's where the pivot took place. Jeff, do you want to, you can explain more about the inner detail.
This thing had been around for many years. As he said, it came on hot at the end because the license was sold a couple of times. Different people were developing it. This thing actually got redesigned after we were awarded the project. It was originally a joint venture with Parks Casino and Cordish Group. Cordish Group then bought out Parks after the design and award was already done, which changed the entire roof of the hotel and some of the geometry and things because they wanted it in the Cordish mindset, not a mix. But really we bid the job with this idea. We're going to erect it ourselves, and we got an erector that did it all the time. But from day one, once we were seriously in the running and having a conversation of doing more than just the soffit and things that weren't panelized on this job, that's what got us in the door to have the conversation, was the limited amount of scope we could bid. It was the parking garage, it was the soffits, it was the portico shear bay ceiling. And I was like, well, we can do more, but how? And then I just threw the idea out. Do you think they'd go for this? And I talked to somebody I knew at the general contractor, and he's like, propose on it. He said, money talks, and the rest of the story. So we went in with an approach, not knowing if it would work. It got us to de-scope. Then it got us in front of the owner and the architect to have a more engaged conversation about the flexibility of the system. And it took from October till February of that process and believing that it would work and doing models and tests for them to see what we would really do before they all bought in and said, we're going with it. So, and I think, being close to $1 million low didn't hurt the situation at the end of the day. It kept us in the room to have the conversation. Right. But I can tell you that would have just meant we made even a lot more money than we did, because the job was beyond successful as done. So you can either take it as I was $1 million low as the estimator, or the person that originally helped design the job and was originally on the job was trying to steal some money or was trying to pad their pockets. So I don't think it's all that my estimate was that low. So
let's talk a little bit more about the money aspects of it. Clearly time was a high priority for this client. But upwards around $1 million less. To a certain extent, I want to dig into that. Like, was that savings on installation and material? Was it carrying costs for the owner?
I've wondered that a lot. Like I said, I don't know how much they had it into it originally. What they thought, if they thought they were going to be the only bidder and they padded it, that I don't know. I can tell you from day one, it was more about, there are jobs, this was the perfect storm. There are jobs where they want everything done and to go, get off the job, the panels are up, you're gone. My philosophy on this job always was the skin was not the critical path of this job. Getting the interior of this with all the fancy architectural elements, all the electrical wiring, security systems, there was so much work inside that the outside was a blip on the radar. So if I could get the skin and give them the selling point of they had more time to think about it, number one, but it got all of my work off the critical path. The majority of this job until the last 6 months was manned with 6 to 8 men doing over 100 and some thousand square feet of the exterior, which is unheard of, because when I bid it, I thought I'd have 25. So it kind of morphed into it was the first time we did it. So there was a learning curve, the advantages we didn't all know. And we put a really good team. I'm gonna put a lot of it on the crews that I had out there and the subcontractors and fabricators that I partnered with and put this job together from day one. It was a partnership. And a lot of collaborative effort that went into it and a lot of hours, not just Monday through Friday, to get this to where it was. Because even something we didn't talk about, the roof screen on the hotel, when the owner bought this old Holiday Inn that they demoed, they didn't realize the cell phone towers on the top of it had licenses to T-Mobile and Sprint and Verizon, some of them in perpetuity. So they still had to keep those cell towers somewhere on their property. Well, when they redesigned the screen, no one thought about the fact that the azimuths for the cell towers can't transmit through metal. So all those panels, wherever the cell towers had to be, we had to redesign all those, and they had to go to FRP panels. But they still wanted to be the same color. They still wanted to be the same modules. So we had to go to a fabricator, then basically make ACM panels, take them to a FRP manufacturer, get the colors matched, have them make the panels so that you drive by, you can't tell that there's plastic panels in the air, 13 stories, that are there. But all the cell towers work now, and that was the biggest. I learned more about cell phones than I ever want to.
Projects always have these tidbits of interesting things you learn that you weren't expecting. I want to go back to the issue of cost, and yeah, we may never know where that $1 million came from. But let's, you guys, you have some expertise as installers, and it seems a little counterintuitive that you've got a prefabricated backup panel, and then you're coming back and stick building. Now, clearly, that's 2 mobilizations.
Yep.
You maybe give us some insight of, and maybe this is just some general insight of, what does that do in the grand scheme of things versus at a fully panelized system versus 2 mobilizations? How can we start to look at this and say, okay, this one's going to be more expensive. This is not going to be.
You got to have it's got to be the right building. First of all, it's got to be balloon framed. For the way we did it, this building was the right height. We could access everything. If you're going to New York and think you're going to do this really easily on a 50-story building where you don't have a tower crane, you're using some kind of derrick, so you're going to be lifting 1 floor at a time with a spider crane from the floors. This isn't the right system. That needs to be a unitized curtain wall. It's got to have the right place. The second thing I would say is back to the partners. I put together a team of people to minimize my exposure. I got the best people. The person that put the panels up, that's all he does. Up and down the East Coast is erect panelized walls. I had a panelizer that built the panels and shipped them, and those two had worked together. So all the models were coordinated, the connections were coordinated. They knew how the trucking was going to come. Obviously, the inflation and costs that exist now didn't exist then for the sheathing and the insulation and all the other stuff that we're dealing with in the construction industry as a whole at the moment. And then what we do, it's a lot of flat walls. This was a perfect job. There isn't a lot of trim. There isn't a lot of windows and openings in the wall. So you aren't stopping and starting your Z-grooves. It's long runs of stuff that if set up right with the crews as far as the insulation that's going in this area and this stuff can go along the way. We also use 2 pieces of equipment that we had never used before called Titan booms. which are a hybrid between a between a typical man lift or a boom lift and God, why didn't the word come to my mind? I want to call it a stage, but it's not a stage. It's a scissor lift. It's a boom, but it has a 20-foot plus or minus by 8-foot basket on the top of the boom lift. We had a 40-footer and a 60-footer, but it also could rotate that whole stage 10 more feet. So in one setup, I could hit 40 foot of wall. And it was already set up with all the hydraulics. I could put saws up there. I could put a bathroom up there. Guys didn't have to get down. All the materials were created and organized, how they would come to a job and where they were going to be for exact areas. It was the logistics and the planning that made the money and saved the money, in my opinion. Now, we did it well and made even more than we had planned. The other stuff, when you have to do the true panelized stuff, that puts the panelizer having to have the electrician come to his shop and install all the lights to his panels. There's time for all that. That's just totally downtime. Why they can't, until they can actually install that, it's just, you're done. You can't put it on the wall till it's 100% ready. And this gave us time. We could actually flow this job and spread it out. I mean, I still have on my wall, I still have a schedule that I made in 2019 pinned to my wall because it was such a detailed schedule and it actually worked, which was amazing. And it was the general contractor, the general contractors of the world. We don't really have many of them. They're all CMs, a lot of them, which wasn't the case when I got into this. But when they understand that they've got to be the partner to their subs and the subs need to be the ones that are successful. If the subs are successful with the general contractor, it's hard for the general contractor not to succeed. And there was partnership even on that level, and you don't always get that. And that's why I kind of say it was the perfect storm, because so many things went right. And it was the planning, it was the coordination, it was going to meeting after meeting after meeting and testing things and seeing if the lights were going to work and how they were going to put them on. We had to put stiffeners in the panels so when the lights were put up, they didn't suck the panel in and destroy the ACM panel, because it wasn't really the panel it was attaching to, it was the blocking we put inside the panel. We had to find the right product for that. It was a lot of over and over testing things, and we made a full-size mock-up for them to check and inspect the whole system up front before we even did anything on the ground. When we hit the ground running, that's exactly what we were doing. We were as efficient as we can be. I'm not saying there weren't snags, there weren't problems, there were. But for the most part, we overcame those, and it was a very proactive job site all the way through.
Great. Well, some interesting concepts we talked about here today. We're coming up on time here, so I think we're going to cut off the Q&A. I want to thank you both for talking to us about this project here today. And for all of the participants that are still on, if you are not a member of the Baltimore chapter of BEC, maybe someone forwarded this to you, please do go to our website and sign up for our email distribution list. You'll be made aware of any upcoming presentations that we have. So I encourage you to go to BEC-Baltimore.org for that. Otherwise, thank you all, Corey and Jeff, and everyone have a great afternoon.
I appreciate the opportunity.
Yeah, absolutely.
Okay,
thanks again. We really appreciate everybody's time. This is not the first time we've done it. So this is the first time we've done it, but we're doing it again now, and we're open to doing it again. So if you run into any panelizations, let us know.